Real-world datasets often contain missing values, which can complicate data analysis. Pandas provides robust methods to handle missing data efficiently. So let's start with creating a simple data frame with some missing values, which are going to be represented with nan, or basically using the numpy library to fill those missing values with nan, or not a number values. And so I'm going to copy over a prepared data frame that I prepared earlier. So we're going to import our pandas and numpy libraries, and we're going to create this basic data frame with some names, ages, and their scores. And we're going to fill just randomly some of these spots with this np nan, or these null or none values, basically representing that this is the missing data within our data frame. So when we run this and take a quick look at our data frame, this is how our data frame looks like, and we have our nan, or missing values. And so usually before that we can handle this missing data, we need to identify where it exists in our data frame. And to do this, we could use the isnull function, which returns a data frame of Boolean values indicating whether each value is missing. So to do that, we will do the df data frame, and we're going to use the isnull method. And when we run that, we can see that we have this data frame, our 3 columns, and in the spots where we have our nan, so row or index by 3 in the name column, that's set to true. So that represents that that is indeed a missing value. Similarly, we could use notnull to represent where there are non-missing values. So instead of isnull, we could do notnull. And when we run that, it does basically the exact opposite. It provides true when it's not null and false when it is a null or missing value. We can calculate the total number of missing values in each column using the sum function along with the isNull. So we could go back to isNull and then calculate the sum. And then we could get for each column how many missing values we have. Now that we know where these missing values are, we can now start to handle them accordingly. And sometimes the simplest way to handle these missing data is to remove it entirely. So if we want to drop all rows that contain any missing values, we would use the dropna function. Again, we have our data frame. Just a quick look again. We have specific rows that contain these nan values. And if we do dot dropna function and we run that, then it drops all the rows that contained the missing values and only left the rows that did not have any missing values. You could also drop columns instead of dropping rows. And to do that, all you would have to do is add the axis parameter and set that to 1. And when we run that, well, in this case, unfortunately, all the columns have some kind of missing value, so all the columns get removed. Often we don't want to lose the data by dropping rows or columns. Instead, we can fill missing values with appropriate substitutions. To do that, we can use the fillna function, which allows us to replace missing values with a specified value. So again, we take a look at our data frame here. We have our missing values, and let's say we want to replace those values with the word unknown. So we could do fillna and then provide the value that we want to fill with, and let's say we want to fill it with unknown. And then when we run that, all those missing values get replaced with unknown. We can also fill the values using what is called a forward fill. And this basically replaces the missing values with the last known value along a specified axis. So again, we have our data frame. with our missing values, we will use the fillna method, and we will use the parameter method, and we will set that to ffill. And then when we run that, we get this filled data frame. And so in the areas where we had missing, so let's say in scores, the third value in that column, which was unknown, that was filled with the value 90 because the previous value was also 90. So it took that value and filled that in right here. Similarly to here, age 24 was the first one, second one was unknown, so we filled it with 24 as well. And same here, Charlie, because previously it was Charlie. Alternatively, we could use the backward fill, which uses the next valid observation to fill the missing value. So instead of the one that was before it, it will use the value after it. So this, all we have to do is just change this to bfill. We run that, and it does the exact opposite. So it takes the value from the bottom and fills it to the top. But in this situation where we had a nan at the very bottom, there was nothing after it, so therefore it just remained as a nan. For numerical columns, it's common to fill missing values with the mean, median, or mode. Let's take a look at our data frame again. And let's say we want to fill the age column. So what we would do is we would take the values in the age column, and we would calculate the mean, or the average age. And then we would use that average to fill those nan values to represent the average age. So to do that, we could create a mean age. And to calculate that, we will use the age column from our data frame and calculate the mean. And then when we print that, we get the mean age. And so now we can use this mean age to fill the data in our data frame. So we will do data frame, and we want to permanently fill that data, because up until now we've been filling the data, but it has not been saved permanently. So to save it permanently, we have to reassign it to that data frame. So our data frame, and we want to fill the age column, or reassign the values to the age column. And again, we use our age column. We want to fill NA. So we want to fill the unknown values with the mean age. And then when we take a look at our data frame, we have calculated the mean age and filled those unknown values with the average. You can also specify different fill values for different columns using a dictionary. So let's create our dictionary, which is going to be fill values. And we're going to provide the key value pairs, where the key is going to be the column name and the value is going to be what value we want to be filling it with. So for the name column, we want to provide value no name, for example, and that's what's going to be used to fill those unknown places. Then we have our age column, and for that we would do by calculating the, let's say, average age, so the mean, so whatever the mean would be that we could fill all those unknown values with. And finally, score, and for that we could calculate, for example, the median. So we use our data frame, selecting the score column, and then calculating the median of those scores. So we have our dictionary, and now we could, let's say, create a new data frame called data frame filled dict, and that is filled with using the fillna method, and we provide the fill values. And when we run that, we also want to take a look at the build the dictionary. And we run that, so we have our no name, which was filled with that. This was, of course, previously already provided the mean or average of the age. And with the scores, we provided the median. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.